Hi everyone, let's draw a nose cone to fit into our top of our fin tube, or if you have a body tube on top of this, into the top of your body tube. Whichever design you have, we're trying to go small at first, so probably just a fin tube, right? Whatever design you have, you want a nose cone that kind of slides right in there, but then clicks into place. And so the way we're going to do it is let's take a look and remind ourselves of the dimensions. I do remember it's 48 on the inside and 50 on the outside, but I want to show you how to check yours in case you forgot. So here's the measure tool. Here's the measure tool. And if I click that inner circle there, it'll tell me its diameter. 48 millimeters across, right? And if I mouse over, I can see a dotted black line. 48 millimeters diameter. Okay. I'm going to click outside to deselect stuff. And how about the outer circle? That's a 50 millimeter diameter. That one there is 50 millimeters across. Okay, so I'm going to remember those numbers: 48 for my inside diameter and 50 for my outside diameter. Okay, now that I know that, I'm going to go over here and I'm going to create a new part studio. And right off the bat, I'm going to right click and rename it, excuse me, as nose cone. Okay, so let's draw on the top plane and look right at it. And remember, I want a section to slide inside of my 48 millimeter tube, my 48 millimeter inside diameter tube. So 48 is not going to do it. It's going to be too big. I'm going to go 47. Oops. I'm going to go about 47.8. I did a slip fit test the other day. I did 47.5 into a 48, and it was just a little bit too loose. And so we can come back and change this if we need to, if further slip fit tests prove this to be a not optimal number, a number that's not quite right. We can come back and fix this. But let's go with just like 0.2 of a millimeter smaller than where we want it to slide into. Okay, well there's that circle. Okay, so I'm going to say, okay, I like that. And there it is. And so now I'm going to do another one. It's got to be 47.8 in outside diameter. But I want it to have an internal diameter also. And I'm going to choose to be 4 millimeters less. Right? So I'm going to go not 47.8, but I'm going to go 47.8 minus 4 is 43.8 millimeters. And the reason I did that was because if this one's 43.8 across, and this one's 47.8 across, then I've got 2 millimeters of material here and here. So I've got a wall thickness of 2 millimeters. And 2 plus 2 is 4, plus the 43.8, sorry, is going to equal our 47.8. Right? So good. I'm going to finish that sketch. I'm going to choose it so it lights up like a ring. I'm going to extrude it, and I think I'll do about 3 centimeters, 30 millimeters, right? And the thing is, let's see, I'm going to draw right on top of this. So, I mean, I could just leave it as it is and create another plane to draw on right on top of the thing, do an offset plane. But you know what? It's going to be easier if we just change the direction of the extrusion. Okay, boom. That way, now it's underneath our top plane. So I can come draw right on top of it very easily. That's just a little bit easier, I think. Either way would work, but I think that's just a bit easier. Okay, so I'm going to look right at my top plane. I'm going to zoom in. And now I need a 50 millimeter circle because I want it to be flush with the outside of the rocket. So 50 millimeters, 50, enter. And likewise, I want the material to be 2 millimeters thick. So I want 2 millimeters extra material inside here, and I want 2 millimeters of material over here. So I'm going to draw another circle, 2 plus 2, 4, less than 50. Right, so I'm going to draw a 46 millimeter circle, 46, bam, and finish that sketch. Come in and choose it so it lights up like a ring. There it goes. And now extrude. I think I'll do another 3 centimeters, 30 millimeters, and say OK. And so now this is starting to look better. I can see already that what I have is a little sort of a cylindrical looking thing, and that part should slide into the rocket body with a couple tenths of a millimeter of clearance. And then this part here should be flush with the outside of the body. It's the same 50 millimeter diameter, which again is entirely too large, at least for a first run. But I'm just sticking with my original measurements so I can keep going with these videos. I hope you're working with smaller numbers. Okay, well that's great. Now let's do a sketch on the front plane. Okay, sketch on the front plane. And the first thing I'm going to do is some lines, right? And the first line I'm going to do is, I think I'll go from here, the center. I'm going to go this way, 25 millimeters, because that's its radius. Right? It's a 50 millimeter diameter. So there's a line, and I'm going to escape out of it. I don't want it over there. And I'm going to draw a line again. And this time I'm going to go up just some distance. I don't know, maybe I'm just going to eyeball it 40-ish. I'm going to call that 40 millimeters up. I've got these two lines here, and I'm going to escape out of the line tool. I've got these two lines here, and I'm going to connect them with a 3-point arc. Here to here. And then I can mess around with it and play with the arc. Do I want a shape like that, or like a big bubble? Something more like this, I would imagine. Something like that. Probably. Okay. We're getting better, but it's still looking kind of pointy up top. If I spin this geometry all the way around, I'm going to have a pointy top. I don't want a pointy top. I really don't. I don't want a pointy top. I want these tops to be kind of rounded out. So let's keep the 3-point arc tool open and just kind of choose a point on that line. Zoom in so we can really see what we're doing here. And another point on this line here. And then get it to be something like that. Good. Snip tool, snip out the other one. Now I've got something that's more rounded, right? And we're looking for kind of rounded nose cones. I don't want sharp points flying around. Sharp points flying around the schoolyards backed by rocket engines. There's something not quite right about that. Okay, so there's my sketch. Easy enough. So I'm going to say, okay, I like it. And I'm going to choose it, the sketch I just did. And I'm going to choose revolve. Okay, so what was chosen? The face of sketch 3. Revolve axis, click there. What do you want to revolve it around? Well, you want to revolve it around that line right there. Okay, so let's revolve it around that line, and there it is. The top to our rocket. Okay, very good. Now there we have a nose cone. The only thing we have to do though is it's not one piece yet. In fact, you can even see through it. So let's just by eyeball grab this one, and translate by XYZ. And I just want to pull it down a little bit so it's just overlapping the other material, just by eye. Just a tiny bit, that much is fine. Okay, good. There's that. Let's make sure it's touching down below. Those were drawn on the same plane, so they're good. Right, and so now you know what we're going to do, right? We're going to turn this into one part. We're going to turn it into one piece by just choosing the whole thing. Just click and drag over the whole thing and go to this little Boolean operator here. And part 1, part 2, let's do it. Click. Now it's one part and you can print it. Oh, almost. Let's do one more thing. That's going to print solid, which might be good to move the center of gravity forward a little bit. But let's try shelling that out first and see how that works. Shell what? That. And there we go. Now I'd call that done. Now it's a hollow tube, a hollow cone, a hollow nose cone. And it's ready to print. Okay, so there's a nose cone for you. Quick and easy. All right. Have a good day. Talk to you soon. Bye.